This is the hypothesis testing after you understand the concepts, how to use the calculator. We're going to look at the same thing that I did in the video about RStudio. We're just going to create a list using these. Part of the reason I'm doing it with this one is because this is the one that actually has only 38 values anyway. So I'm going to import that. And what I want to look at is annual income. These are the top bull riders, and in the previous video I compared them to 3 different things, I guess, and this one may be the previous to you, but you can create a column that gives you average earnings and type that in. Okay, so the way you would do that is say within bull, I want to create an annual column, and that's just going to be earnings divided by years pro. And then reload bull, and it's there. If you don't like RStudio at all, and what you want to do is just put it all in the calculator, you can. So you have 2 columns, years pro and earnings. And you would type these in. Oops. Bring this over. So you'd first add list and spreadsheet, and then we're going to have a years pro column, and we're going to have an earnings column. Oh, that's interesting. It just copied the ones I already made. So let me start this over. Oh, that's irritating. Okay. I did the wrong thing. So what we want to do is add a page and add list and spreadsheet. Same over here. Let me see if it remembers it. No. Years pro earnings. So you do it like this. On the years pro, you have 5, 5, 7, 8, 7, and so forth. And on earnings, 146, 4475.61, 226255.5. Okay, so there are the first several. And so I've gone ahead and done this all now over here so that we have all 38 values. And what I want to do over here then, we'll call this annual, is I'm going to take the earnings, so B1, divided by the years, so A1. And then I'm going to copy that. Oops. Oh my. Down. Okay, so that we get everybody's average annual income here. So I want to do a hypothesis test between annual income, which again, I could have also done the average in the spreadsheet, I could have done that here and just copied in the annual earnings. Normally you won't have this many and they won't be this weird. Normally, even if, you know, with a calculator you'll have weight or height or something smaller. I'm just doing this as something to do that I know you won't be assigned. So, the annual income here, we want to compare it. So I'm going to go menu, statistics. So if we want to have the mean and the standard deviation, we'd go to one variable stats, and we want one list, and the list we want is annual. That's what we want to look at. And I think column E is an okay place to put it. Yeah, so that leaves D even open. So there's the average. And before I compared it first to a ranch hand, which had a 29,000, so we'll do that too. And then I compared it to teachers, which I think I still have open over here. Yeah. There's the average. There's the SD, which is the same that we got when I did it on the RStudio. So G will be where we want our next thing to appear. So now I want to do statistics t-test. Data is the method because it has the list. If I was telling it the mean and standard deviation and N, then I would do statistics instead there. But I'm giving it all the values, so data. The thing we're comparing it to first is the ranch hands, 29,000. And the list I want is annual. We're doing this so we can do any of these tests, but we're doing the two-tailed test. And the result column, I think I said G actually. We'll let it be H, it's fine. So I go OK. And then we get the t-statistic. The p-value is huge. The t-statistic we would compare to the value on the t-chart if we were using that. The p-value we compare directly to alpha. This says there's actually a 95% chance that I would get this average if they had the exact same salary as a ranch hand. So this is not at all statistically significant. And then the degrees of freedom, 37. Now let's see, I want to have J or K, I guess, is my results. I want to do stat tests, t-test, data again. This time I wanted to compare it to the average teacher salary, which was 46492. If I do this, it's going to give me a little, oh, it's weird. I guess I didn't click something. Let me try this again. That is not what I wanted. Okay, data. Oh, so 46492. And here I want to choose annual. Okay. So when I do this, it gives me this little normal curve, and you see how it's shaded in the two regions that make up the p-value? So those added together are 0.0266. So let's say that we were using an alpha of 0.05. Because 0.0266 is less than 0.05, we would reject the null hypothesis. So we would say it is not the case that these top paid professional bull riders make the same as teachers. In fact, they make less, which is bad. It's a dangerous job. You definitely should not do it. So this p-value we would compare to alpha. If instead we wanted to compare the t-value, we'd come to the t-table, and for alpha equal 0.05, we look at a single tail of 0.025 because they need to add up. to 0.05. So 0.025 here, we would go down for degrees of freedom, and we want degrees of freedom 30. They were 37, but we want to play, cautiously, so we'd choose the 30. So 2.042 is what would compare T to, 2.042, and it was 2.31 or 309. We forget the negative, right, because the tail is always shown to be the upper tail for the T-chart. So we look at it and we say 2.042 is less than 2.309, so 2.309 is in the critical region, which again would mean we reject the null hypothesis. And you can look over here. It's obviously right here on the table as well, but if you needed the degrees of freedom, this actually gives you the average in the SD as well, and N. So you didn't have to run the one variable stats to get those. In RStudio, it does not give you those values, so you have to run the mean and standard deviation separately. So this is exactly the same information as we got from RStudio. This is just how to get it from a calculator. So we reject the null.